On July 1st, 2025, a small telescope in the mountains of Chile caught something moving through the sky that didn't belong to us. Never once in the entire history of our solar system been gravitationally bound to our sun. It was moving too fast, on a path too sharp, to have come from anywhere nearby. It had come from somewhere else entirely, from interstellar space, from a star system. We'll probably never identify, on a trajectory that would carry it through our solar system exactly once, and then send it back out into the dark, never to return. Astronomers named it 3I Atlas. And within months, one of the most respected astrophysicists in the world would be telling the public that this object might not be what it appears to be at all, setting off a public argument that pulled in NASA scientists, independent researchers, radio astronomers, and eventually some of the most powerful telescopes ever built, all racing to answer a single question before the object slipped back out of reach for good. This is the story of what 3I Atlas actually is, what it actually did on its way through our solar system, and why a serious scientific argument broke out over whether we were watching a comet or something that wanted us to think it was one, and why the answer that finally emerged says more about how good our science has gotten than it does about anything lurking out among the stars. Start with the basics, because they're strange enough on their own. 3I Atlas is only the third interstellar object ever detected passing through our solar system, after Oumuamua in 2017 and Comet Borisov in 2019. It was picked up by the NASA-funded Atlas survey system, the same network of telescopes built specifically to catch fast-moving objects before they get too close to Earth. From the moment of discovery, its orbit gave it away. A hyperbolic trajectory, open rather than closed, meaning it isn't looping around our sun the way every planet and ordinary comet does. It's simply passing through, on a path that traces back to somewhere outside our solar system entirely, and that will carry it back out into interstellar space for good once it leaves. It's also, by some measures, the largest and fastest interstellar visitor ever recorded. Estimates place its nucleus somewhere between roughly 440 meters and 5.5 kilometers across, moving at well over 130,000 miles an hour even before the sun's gravity sped it up further, eventually reaching around 153,000 miles an hour at its closest approach. Every major observatory capable of pointing at it did. Hubble, the James Webb Space Telescope, ground-based observatories across multiple continents, even spacecraft already stationed around Mars and out near Jupiter got turned toward it for a look. The European Space Agency redirected instruments on its Mars Express orbiter, its ExoMars Trace Gas orbiter, and the Jupiter-bound JUICE spacecraft to catch glimpses from angles no Earth-based telescope could match, giving scientists a multi-vantage point view of an interstellar object for the first time in history. By the numbers alone, this was already one of the most closely observed objects to ever pass through our neighborhood. Even at a purely technical level, the object never came close enough to threaten Earth. Its nearest approach to our planet was roughly 170 million miles away, and its closest pass by the Sun kept it just inside the orbit of Mars, safely distant by any planetary defense standard. NASA was explicit about this from early in the observation campaign. 3I Atlas posed no danger, and nothing in its trajectory ever suggested otherwise. Whatever fears the object's discovery stirred up publicly. An impact, or a close call, was never one of the credible ones, and the closer astronomers looked, the stranger some of the data got. Webb's early spectral readings showed something unusual, an atmosphere, or coma, dominated by carbon dioxide rather than the water vapor that typically dominates comets at that distance from the Sun. Later observations detected large amounts of nickel relative to iron, an unusual ratio compared to most solar system comets. Some data sets showed a faint anti-tail, a stream of dust appearing to point sunward instead of away from the Sun, the opposite of what a typical comet tail usually does. And then there was the detail that ended up generating the most public attention of all, a rhythmic variation in the object's brightness, repeating roughly every 16 hours that one prominent scientist would eventually describe, in public, using a word that had nothing to do with astrophysics at all. That scientist was Avi Loeb, a Harvard astrophysicist with a long, well-documented history of pushing the astronomical community to take the possibility of alien technology seriously, going back to his earlier claims about Oumuamua in 2017, where he argued that objects' own unexplained acceleration might point toward an artificial origin, possibly a discarded solar sail. Loeb looked at the growing list of oddities around 3I Atlas, the trajectory, the size, the nickel ratio, the anti-tail, and that pulsing 16-hour brightness cycle, and argued across a series of papers and public essays that, taken together, they were statistically unusual enough to at least justify asking whether this object might be something other than a natural comet. In one preprint, Loeb and his co-authors calculated a small but measurable non-gravitational acceleration in the object's path, the same category of anomaly that had originally fueled his Oumuamua argument years earlier. He described the brightness pulse using the word heartbeat, suggesting it could represent something closer to a mechanical or operational cycle than the random tumbling typically expected from a chunk of ice and rock. He went further still, floating the idea that the pulses might represent periodic thruster activity, adjusting the object's course, and at one point suggested 3I Atlas might even be traveling in loose coordination with a second, unrelated comet, hypothesizing the two could share a common technological origin, a claim he himself qualified carefully, noting that the connection would only make sense if genuine artificial propulsion were involved. To be clear about what that claim actually was and wasn't, Loeb was not reporting a detected transmission. No signal, no message, no communication of any kind was received from 3I Atlas by Loeb, by NASA, or by anyone else. What he was describing was a pattern in the object's reflected sunlight, brightness rising and falling on a repeating cycle, the kind of thing that can show up in a tumbling asteroid, an irregularly shaped comet nucleus catching sunlight at different angles as it rotates, or, in Loeb's minority interpretation, something built rather than born. He framed it as one anomaly among several, arguing that the pattern of unusual features taken together was worth investigating rather than dismissing outright. The mainstream response was fast and largely unified. NASA's own lead scientist for small solar system bodies described 3I Atlas in blunt terms. It looks like a comet, and it does comet things. Researchers pointed to ultraviolet observations detecting hydroxyl emissions, a telltale signature of water ice vaporizing under sunlight, exactly the kind of outgassing you'd expect from an ordinary icy body warming as it approached the sun. Independent teams reanalyzing the same brightness data that produced Loeb's. A heartbeat argued the 16-hour cycle was fully consistent with a naturally rotating, irregularly shaped nucleus. Nothing about the period or the pattern required anything beyond known physics to explain. And then came the most direct test available. Astronomers didn't just debate the brightness data. They pointed radio telescopes at 3I Atlas and specifically searched for artificial signals, the same kind of technosignature search used in traditional SETI research. The result, published in a study still awaiting peer review as of this writing, found no credible detections of narrowband radio signals coming from the object. In plain terms, they listened, specifically, for exactly the kind of transmission the title of this story promises. They didn't find one. That result didn't end the argument. Loeb continued publishing follow-up essays defending the broader anomaly list, arguing that dismissing unusual features without fully explaining them risks discouraging the kind of open scientific inquiry that led to major discoveries in the past. He went so far as to argue that excluding anomalies from official communications, rather than addressing them directly, risked alienating the public by appearing to dodge uncomfortable questions, rather than answering them. Critics, including astronomers who've spent their careers studying comets and interstellar objects, pushed back hard, arguing that each individual anomaly Loeb raised had a plausible natural explanation once examined carefully, and that treating a pattern of coincidences as evidence of engineering, rather than evidence of how strange and understudied interstellar objects genuinely are, was overstating what the data could support. One widely circulated technical rebuttal went through each of Loeb's cited anomalies in turn, arguing that the underlying observations were real, but that the technological interpretation required stacking multiple independent, low probability assumptions on top of each other, when a single more mundane explanation, an unusually large, unusually old, unusually eccentric comet, accounted for nearly all of them at once. Some described the broader pattern of high-profile claims, followed by mainstream rebuttal, as a repeat of the exact same cycle that played out with Oumuamua 8 years earlier. Global headlines, methodical scientific pushback, and eventually a natural explanation that simply didn't generate as much attention as the alien hypothesis had. Even in scientific communities not typically prone to public sparring, the debate spilled into open forums where working astronomers and enthusiasts alike dissected Loeb's claims point by point, reflecting a broader frustration among scientists that high-profile speculation, however well-intentioned, can outrun what the underlying data actually supports. It's a pattern Loeb himself would likely acknowledge, even while defending his approach. He has framed his position not as certainty that 3I Atlas is artificial, but as an argument that the possibility deserves serious investigation rather than reflexive dismissal, a stance he's applied consistently across every interstellar object discovered since Oumuamua, and one that has earned him both prominent public attention and consistent criticism from within his own field for prioritizing headline-generating hypotheses over more conservative, incremental analysis. By the time 3I Atlas reached its closest point to the Sun in late October 2025, remaining safely outside Earth's orbit the entire time and never posing any real threat to our planet, the weight of the observational evidence had shifted firmly toward the natural explanation. Webb's later spectral data showed water vapor increasing exactly as expected as the comet warmed further, joining the carbon dioxide detected earlier in a chemical signature that, while unusual in its exact proportions, still fit within the known range of cometary behavior. X-ray telescopes detected a faint glow around the nucleus, consistent with known interactions between cometary gas and the solar wind. The first time that kind of signature had ever been. Captured from an interstellar object, a genuine scientific milestone in its own right, and one that had nothing to do with anything artificial. Ground-based telescopes tracking the object's coma over dozens of nights recorded wobbling jets of dust that researchers linked to the natural rotation of an irregularly shaped nucleus, roughly once every 15.5 hours, close enough to the heartbeat figure Loeb had cited that some researchers saw it as the natural explanation hiding in plain sight all along. Later analysis even suggested 3I Stezid Atlas could be extraordinarily old, potentially older than our own solar system, a frozen relic drifting between stars for billions of years before we ever caught a glimpse of it. A finding that, if anything, made the object more scientifically remarkable, not less, without requiring any explanation beyond conventional astrophysics. So what does that leave us with? Not a confirmed transmission, not a confirmed threat. What the evidence actually confirms is something almost the opposite of what a headline like this promises. An extraordinarily rare natural object, ancient beyond easy comprehension, behaving the way comets behave, radio silent under direct and deliberate scrutiny, now heading back out toward the space between the stars, never to pass this way again. But it's worth being honest about why the alien hypothesis got as much traction as it did, because that part isn't nothing either. 3I Atlas really was unusually large. Its trajectory really was unusually well aligned in ways some researchers found statistically striking, and its chemistry really did differ from most of the comets we've cataloged inside our own solar system. The scientific process that played out here, publicly, in real time, argument and counter-argument, prediction and test, is exactly how these questions are supposed to get resolved, not by declaring a verdict on day one, but by pointing every available instrument at the object and letting the data settle it. That process did what it was supposed to do. It just settled this time on comet rather than probe. And it's worth remembering that the same open-minded scrutiny that let Loeb's hypothesis get a public hearing is the same rigor that ultimately dismantled it. The process worked precisely because nobody, on either side, got the final word simply by asserting it loudest. The real story of 3I Atlas isn't a message from the stars confirming anything anyone feared. It's a much quieter kind of confirmation, proof that when something genuinely unfamiliar shows up in our sky, we now have the telescopes, the instruments, and the scientific rigor to actually study it properly instead of just guessing. 3I Atlas is already on its way out, climbing back toward the orbit of Jupiter and beyond, carrying whatever secrets its ancient ice still holds out into the dark it came from. We may never know exactly which star it began its journey around, but we do know, with far more confidence than the headline suggested, exactly what it was doing here, and it wasn't sending us anything at all. Somewhere out there, a fourth interstellar object is already on its way, and next time, the same argument will almost certainly happen again.